In today's session, we are going to discuss about the section formula and two of its applications, namely the midpoint formula and formula for centroid of a triangle. So let us see what is the use of the section formula before we derive the section formula. Suppose we are given a line segment that joins 2 points A and B. Let us assume that the coordinates of A are x1, y1 and the coordinates of B are x2, y2. Let P be a point. Let P be a point on AB that divides the join of A of x1, y1 and B of x2, y2 in the ratio m:n. So please note that P is a point on AB. It can be situated anywhere on AB such that P divides the join of A of x1, y1. So now please understand that A is the first point that is mentioned. Therefore, the numerator of the ratio is also with respect to the point A. What I mean by that is, suppose the point P is situated here, then there are two ways to look at this, right? So either the ratio, so P divides AB in the ratio m:n, or it could also be n:m. So which one of these two is right? That is the question. Well, because A is the first point that is mentioned, we always take the distance from the point A as the numerator. That means the distance between AP is to PB, right? So the distance AP is to PB is going to be in the ratio m:n. So whatever is the first point that is mentioned, here A is the first point which is mentioned, the distance of that particular point P from the first point A is going to be the numerator of this particular ratio. So the use of this particular formula is, if you have the coordinates of A and B and you want to find the coordinates of a point P which divides AB in the ratio m:n, then it is possible to find the coordinates of point P. Therefore, I can say that coordinates of point P can be found out using the section formula. So the formula for coordinates of P is going to be, and of course we are going to derive this, it is going to be m times x2 plus n times x1 divided by m plus n, comma my2 plus ny1 divided by m plus n. So the use of section formula is that you can find the coordinate of any point on this particular line segment AB, where the point P is dividing this particular line segment into two sections. One is AP and one is PB in a specified ratio, which is m:n. So let us take some more examples and understand what the section formula is doing for us. So let us consider 2 points, A of 2, 3 and B of 8, 15. Now I want to find a point on this particular line segment such that P divides P divides AB in the ratio, P divides AB in the ratio 2:3. Okay. So that means since A is the first point that is mentioned, the length 2 corresponds to the point A. So what it means is, if I mark a point P over here, the distance AP is to PB is going to be 2:3. This is the ratio. Now why didn't I write it as 3:2? What is wrong with writing it as 3:2? I cannot write it as 3:2 because A is the first point that is mentioned and the numerator of the ratio is 2. It means that the distance of the point P from A to the distance of the point B from P, or the ratio of length AP to PB, is going to be 2:3, and that is why AP is to PB is written as 2:3. That is why this is the right ratio that I have taken, 2:3. Now the section formula is quite simple. If I want to find the coordinate of P, then I can find it as follows. Please note that there is a cross coupling effect in the section formula. What I mean by that is, right now I am finding the x coordinate of P. I am finding the x coordinate of P, and later on I will find the y coordinate of P. So to find the x coordinate of P, I will consider both the x coordinates. So 2 is the x coordinate of A, 8 is the x coordinate of B, and then I am going to have a cross coupling effect. So I will multiply 2 with 8. So it's going to be 2 into 8 plus 3 multiplied by 2 plus 3 multiplied by 2, the whole divided by the addition of these ratios, which is 2 plus 3. And now if I wish to find the y coordinate, then I will have to have cross multiplication of the y coordinate. So what are the y coordinates of A? The y coordinate of A is 3 and the y coordinate of B is 15. So the y coordinate of P is going to be 2 multiplied by 15, 2 multiplied by 15 plus 3 multiplied by 3, 3 multiplied by 3 divided by 2 plus 3. Therefore, the coordinate is going to be 16 plus 6 divided by 5, comma, this is 30 plus 9 is 39 divided by 5. Therefore, the coordinate of P is going to be 22 upon 5, comma 39 upon 5. So using this particular section formula, I was able to find the coordinate of P provided the ratio was given. So let me now take one more example. Let's consider a line segment AB. A has coordinates 2, -3 and B has coordinates 12, 12. Let C divide. Let us say that C divides the join of A and B, in the ratio 1:4, whereas D divides the join of A and B in the ratio 4:1. Let us now use the section formula to find the coordinates of C and D. So C divides the join of A and B in the ratio 1:4. That means the distance between C and A is to the distance between C and B is in the ratio 1:4. So the point is closer to A as compared to B because the ratio is 1:4. So this is the point C. And on the other hand, D divides the join of A and B in the ratio 4:1. That means the distance of D and A, that is DA, is to the distance between D and B, DB, is equal to 4:1. and therefore the point D is way closer to the point B. That means the ratio, if I consider this is D, then this particular ratio is 4:1, right? So this is how I can draw the diagram for this particular question. I will pause for a couple of seconds. Please understand this correlation of how to write the right ratios, and then we will find the coordinates of C and D using the section formula. Okay, let us now find the coordinates of C. So for the time being, I am going to erase the ratio for D. So let us focus completely on the coordinates for C. So now if you consider the point C, we will have a cross coupling effect. So this is going to be the coordinates of point C. Let us first find the x coordinate. For finding the x coordinate, let us pick the x coordinates of A and B and let us have a cross coupling effect. So 1 multiplied by 12 plus 4 multiplied by 2, right? 4 multiplied by 2 divided by 1 plus 4, comma, now let us find the y coordinate of this point C. So for finding the y coordinate, again I will take the y coordinates of A and B. So y coordinate of A is -3, the y coordinate of B is 12. So again applying the cross coupling idea, 1 multiplied by 12, so 1 multiplied by 12 plus 4 multiplied by -3 plus 4 multiplied by -3 divided by 1 plus 4, and therefore these coordinates are going to be, this is 12 plus 8, that's 20 upon 5, comma, this is 12 minus 12 upon 5, and therefore the coordinate of point C is going to be 4, 0. So I will pause for a couple of seconds and then we will go ahead and find the coordinate of D. Okay, let us now go ahead and find the coordinates of D. So now it is given that D divides the join of AB in the ratio 4:1, which means the distance of D from A is to the distance of D from B is 4:1, right? And now we need to find the coordinates of the point D. So to find the x coordinate of point D, I am going to take up the x coordinates of A and B. X coordinate of A is 2, x coordinate of B is 12. So let us find the x coordinate of D now. There is going to be a cross coupling effect. So that means it's going to be 4 into 12. So 4 into 12 plus 1 multiplied by 2. If you notice, I am cross multiplying the ratio with the coordinate. So 1 multiplied by 2 divided by 4 plus 1. And to find the y coordinate of D, it's 4 multiplied by 12. So 4 multiplied by 12 plus 1 multiplied by -3. So 1 multiplied by -3 divided by 4 plus 1. So this is going to be 48 plus 2. So 48 plus 2 upon 5. and this is going to be 48 minus 3 upon 5. And if you calculate this, this is 50 upon 5, which is 10, and 45 upon 5, which is 9. Therefore, the coordinate of point D is going to be 10, 9. This is how I can use section formula to calculate the coordinates of different points that lie on this line segment. Now, of course, I can also use section formula to find the coordinates of points that lie beyond B as well as beyond A. But right now, here, we are going to restrict our focus only on points that lie on line segment AB. Such a division is called a point dividing the line segment internally. So what I mean by that is, assume that you have a line segment AB, okay, and if C divides the line segment joining A and B internally in the ratio m:n, it means that the point is internal to this line segment. So the point C is somewhere here, such that the ratio is m:n, right? This is the meaning of C divides the line segment joining A and B internally. Internally means the point C lies on the line segment AB. So now let us go ahead and derive this section formula. So let us consider a 2D plane where we have the y-axis and the x-axis, and A and B are the 2 points that are marked on this particular 2D plane. Let us now mark some x and y coordinates. So A has coordinates x1, y1, B has coordinates x2, y2, and point P has coordinates x, y. So our goal right now is to find a formula for finding x and y, basically the coordinates of P. It is known that P divides the join of AB in the ratio m:n. So m:n is the ratio, which means that the actual distance is m times k multiplied by n times k, where k is the common ratio. So I know that AP is to PB is basically m:n, which implies that I can say AP, the distance AP is mk, and the distance PB is equal to nk, where k is the common ratio. Now let us mark a few x and y coordinates. So we know that the distance between the y-axis and the different points is going to be their x coordinates. So this length is x1. The distance between the origin and the point M is x1. The distance between the origin and the point N is x, because that's the x coordinate of point P. And the distance between the point O and R, the horizontal distance, is x2. Similarly, the distance between Q and R is y1, because that's the y coordinate of point A. And the distance between S and R is going to be y, because that's the y coordinate of point P. And of course, the distance BR is going to be y2. So if this is the case, then we can do a few more markings. So let us do a few more markings now. So if you consider the following diagram now, I have found the distances between A and Q, the distance between the different points that are located on the triangle. So right now my focus is going to be to use the first triangle, that is this particular triangle. If you notice, these two angles are equal because they are corresponding angles. So I am going to use trigonometry over here to find a few ratios. So first of all, let's consider this particular triangle. So in triangle APT, I know that the hypotenuse is m times k. The distance between P and T is y minus y1, and the distance between A and T is going to be x minus x1. So I can use the trigonometric ratio sine theta. So if I use sine theta in this triangle, I know that sine theta equals the opposite side, which is y minus y1 divided by the hypotenuse, which is equal to m times k. So this gives me one relation between y, y1 and m. Similarly, now what I am going to do is, I am going to consider the whole triangle, which is AQB, right? So let's consider the triangle AQB. So AQB is also a right angle triangle with the same angle theta. So I can say in triangle AQB, again I want to find sine theta. So sine theta is again going to be the opposite side. The opposite side is BQ. Now BQ is going to be the difference in the y coordinates of point B and A. So BQ is marked as y2 minus y1. So y2 minus y1 upon the hypotenuse is mk plus nk, right? Now if you notice, theta is same in both the triangles. Therefore, I can say that y minus y1 upon mk should be equal to y2 minus y1 upon, I can take a k common in these two terms. So k bracket m plus n. Now the term k cancels from both sides and therefore I get y minus y1 upon m is equal to y2 minus y1 upon m plus n. So what I notice is I now have a relation between y, y1, y2, m and n. What am I trying to find right now? I am trying to find the formula for y. So this is what I am trying to find. So now my sense of mathematics tells me that shift all the other terms to the right hand side and find the formula for y. Therefore, y minus y1 is going to be m times y2 minus y1, that is m by 2 minus m by 1 divided by m plus n. And now I can shift the term y1 to the other side. So I get y equals m by 2 minus m by 1 upon m plus n plus y1. Now of course I can find the LCM. Therefore the LCM is going to be m plus n, right? This is the denominator. And in the numerator I will have m by 2 minus m by 1. And when I take the LCM is m plus n. So the numerator will now change to plus m by 1 plus n by 1, right? This is going to be the numerator. When I multiply m plus n with y1, this is what I am going to get. And now minus m by 1 plus m by 1 cancels, and therefore I get y equals m by 2 plus n by 1 divided by m plus n. This is the formula for the y coordinate. Now if you notice, this basically shows that there is a cross coupling effect. We take the value of m and we multiply with the y coordinate of b, plus we take n and we multiply with the y coordinate of a divided by m plus n. So this is how we find the y coordinate of the point P, and we were able to find the y coordinate because we took the trigonometric ratio sine. So instead of sine, if we take the ratio cos, then we will be able to find the value of the x coordinate. So I will pause for a minute while you take a look at this derivation for y, and then we will go ahead and derive the formula for the x coordinate. While you take a look at the derivation, first take a look at all these lengths of AT, PT, AQ, BQ and so on. That is going to be very important. Let us now go ahead and derive the formula for for x. So now again, if I consider the triangle APT and if I take the trigonometric ratio cos, I can say that in triangle APT, cos theta is equal to the adjacent side, which is x minus x1 divided by the hypotenuse. Hypotenuse is equal to mk. And similarly in triangle ABQ, so let us shade the triangle ABQ, that is this whole triangle. In this whole triangle, if I consider cos theta, so in this triangle cos theta, in this whole triangle ABQ, cos theta is going to be x2 minus x1 divided by the hypotenuse, which is mk plus nk. So again, because theta is the same, cos theta is also the same in both the triangles. Therefore, I can say x minus x1 divided by mk is equal to x2 minus x1 divided by mk plus nk. And therefore, x minus x1 divided by mk is equal to x2 minus x1 divided by m plus n times k. The value of k cancels from both the denominators, and therefore we get x minus x1 by m is equal to x2 minus x1 by m plus n, and cross multiplying I get x minus x1 is m gets multiplied with x2, so you get mx2 minus mx1 divided by m plus n. So again, in this particular derivation, I am trying to find the formula for x. So I am shifting all the other terms to the other side. And now let me shift the x1 to the other side. So I get x is equal to mx2 minus nx1 divided by m plus n. And the minus x1 becomes plus x1 on the right hand side. And taking the LCM, I get x equals mx2 minus mx1 plus the LCM is m plus n, of course. So x1 gets multiplied with m as well as n. So you get plus mx1 plus nx1, the whole divided by m plus n. Now minus mx1 and plus mx1 cancels, and therefore the x coordinate is equal to mx2 plus nx1, the whole divided by m plus n. This is the formula to find the x coordinate of the point. Again, you will notice that there is a cross coupling effect. So m gets multiplied with the x coordinate of b, n gets multiplied with the x coordinate of a divided by m plus n. Therefore, the formula for x is mx2 plus nx1, the whole divided by m plus n. This is the value for the x coordinate of the point P. So this is the derivation of the section formula. Of course, you can derive the same result even using the similarity, properties of similarity. So because triangle APT and triangle ABQ are similar, you could have also used similarity, but because trigonometry is one of the many manifestations of similarity, that is why I use trigonometry to find the formula. So this is how the section formula is derived. Pausing for a minute while you digest this information. So let us summarize the section formula in a nutshell. So let's consider that A and B are 2 points whose coordinates are x1, y1 and x2, y2 respectively. And P divides the join of A and B in the ratio m:(n). Because A was the point that was specified first, m lies on that side and therefore the ratio is m:(n). Then section formula says that the x coordinate of P and the y coordinate of P can be found as follows. So for the x coordinate of P, consider the x coordinates of A and B and cross multiply them with m and n. So m gets multiplied with x2 and n gets multiplied with x1. So mx2 plus nx1 upon m plus n. And to find the y coordinate, it is going to be m by 2 plus n times y1 divided by m plus n. This is how you can find the x and y coordinates of the point P. This formula is called the section formula. Now, one of the important outcomes of the section formula happens to be the midpoint formula. So let's understand the midpoint formula in brief. In case I have A and B, okay, these are the coordinates x1, y1 and x2, y2. So let us label this as the section formula. So now let us assume that there's another point Q which is located at the midpoint of A and B. Because it is located at the midpoint, Q divides, I can say that since Q is the midpoint of AB, I can say that Q divides AB in the ratio 1:1. That means this is 1:1, right? And therefore I can find the coordinate of Q. So coordinate of Q therefore is going to be, now instead of m I have 1, right? So I can substitute m as 1, and instead of n also I have the value 1. So let me substitute this in the section formula. So 1 multiplied by x2 plus 1 multiplied by x1 upon 1 plus 1, comma 1 multiplied by y2 plus 1 multiplied by y1 upon 1 plus 1, which means that this is nothing but x2 plus x1 by 2, comma y2 plus y1 divided by 2. Therefore, the midpoint formula helps us find the coordinates of the midpoint. The coordinate of the midpoint is basically going to be the average of the two coordinates. So average of the x coordinates of A and B gives me the x coordinate of Q, and the average of the y coordinate of A and B gives me the y coordinate of the point Q. This particular formula is called the midpoint formula because it helps us find the coordinates of the midpoint. So I will pause for a minute, take a look at how we derive the midpoint formula and also try to understand the pattern that you see in the section formula. Let us now apply what we have learnt in section formula and find the centroid of a triangle. So let's consider a triangle ABC with coordinates of x1, y1, b of x2, y2 and c of x3, y3. Let us define what is a centroid. So centroid is basically a point where all the medians will intersect, right? So a median is basically a line that joins or a line segment that joins the vertex of a triangle with the midpoint of the opposite side. So this is the point M, and therefore AM is one of the medians. M is the midpoint of BC. So is it possible to calculate the coordinates of M? Using midpoint formula, I can now find the coordinates of M. So using midpoint formula, I can say that the coordinates of M is the midpoint of BC. So the coordinates of M are basically going to be the average of coordinates of B and C. The x coordinate of M is going to be the average of the x coordinates of B and C. So it is going to be x2 plus x3 divided by 2, comma y2 plus y3 the whole divided by 2, because the midpoint formula says that the x and y coordinates are basically the average of the coordinates of the endpoints of the line segment. So coordinate of M is going to be x2 plus x3 by 2, comma y2 plus y3 by 2. Now the point centroid is going to lie on this median in such a way that its distance from the vertex to the distance from the midpoint, this is always in the ratio 2:1, right? And this particular point can be proved using similarity. So centroid is always marked by the point G. So centroid is represented by the point G. Centroid is the point where all the medians meet each other. So of course, if you draw one more median, say for example passing through C, then the point where these two medians meet is basically the centroid, right? So this is another midpoint. So N is the midpoint of AB. So CN is also a median, AM is also a median, and these two medians intersect at point G. And we know that the centroid divides the join of the median in the ratio 2:1. So now imagine the line segment AM. So let me just draw the line segment AM over here. So this is the line segment AM. The coordinate of A is x1, y1. The coordinate of M is given by x2 plus x3 by 2, y2 plus y3 by 2. And the centroid lies on this line in such a way that the ratio is 2:1. And you can prove this particular property using similarity, which I will do in the next section. Yeah. So now I can use to locate the coordinate of G, I can definitely use section formula, because coordinate of A is known, coordinate of M is known, and G is dividing AM in the ratio 2:1. So G divides AM in the ratio 2:1, and therefore coordinate of G. So let's find the coordinates of G. To find the x coordinate, let us focus on the x coordinates of A, x coordinate of M, and of course M is to N. So now there is a cross coupling effect. So this is going to be 2 times. So this 2 gets multiplied with the x coordinate of M, that's x2 plus x3 by 2, plus 1 gets multiplied with x1, so that's 1 multiplied by x1 divided by 1 plus 2. This is the x coordinate of G, and the y coordinate of G. So to find the y coordinate of G, I take M, I cross multiply it with the y coordinate of M. So it becomes 2 multiplied by y2 plus y3 by 2 plus 1 multiplied by y1. So that's 1 multiplied by y1 divided by 1 plus 2. So now if you think about it, 2 and 2 gets cancelled, 2 and 2 gets cancelled. Therefore, this formula, the formula for centroid of a triangle becomes x2 plus x3 plus x1 divided by 1 plus 2, which is 3, comma, over here 2 and 2 got cancelled, so y2 plus y3 plus y1, y2 plus y3 plus y1, the whole divided by 3. And therefore the coordinate of centroid, if you take a look at it very carefully, centroid G is given by the x coordinate is the average of all the 3 x coordinates. So it is going to be the centroid G has x coordinates x1 plus x2 plus x3 upon 3, comma, y1 plus y2 plus y3 upon 3. So if you try to think about it, midpoint was basically the average of the 2 points that of whose midpoint we were trying to find. So in midpoint formula, you had addition of the x coordinates divided by 2 and addition of the y coordinates divided by 3, divided by 2 again. In centroid, to find the x coordinate of the centroid, it is addition of all the x coordinates, addition of the x coordinates of these 3 points divided by 3 and the addition of all y coordinates divided by 3. This is how you can see a pattern between the midpoint formula and the centroid formula. So I will pause for a minute while you take a look at this derivation and then we shall continue. So now let us prove that centroid divides a median in the ratio 2:1. So ABC is a triangle and let me first take the midpoint of, say, the side AB. Let this midpoint be M and let the midpoint of AC be point M. So now I am going to join CM and CM is one median, whereas BN is the other median, and these two medians intersect at the point which is G over here, and G happens to be the centroid. So of course if you draw the third median, it will pass through the point G. Now we have to show that the ratio BG is to GN is 2:1. Basically the distance of the centroid from the vertex and the distance of the centroid from the midpoint is always in the ratio 2:1. This is what we have to show. So what I will do is I will join M and N, and I know that according to the midpoint theorem, so why can I apply midpoint theorem here? Because M is the midpoint of AB, and N is the midpoint of AC. Therefore, I can definitely apply the midpoint theorem. I know that according to midpoint theorem, MN is parallel to BC. So let me mark that. So MN is parallel to BC, and I also know that MN is half of BC, which means that if MN is marked as X, then BC is marked as 2X. BC is basically twice the length of MN. Now I can pick these two triangles for similarity. I know that these two triangles are similar by the AA test, because these two lines are parallel. MN is parallel to BC, which means that the angle M here is equal to angle C, alternate interior angles. And similarly, I have angle N equal to angle B in this triangle, again because of alternate interior angles. So I can say that triangle MGN is similar to triangle CGB according to the AA test. And therefore, if I take the ratio of the sides, I can say that MG upon CG is equal to GN divided by GB is equal to MN divided by CB. Now I know that if Mn is x, I have taken Mn as x here, right? So the length of Mn is x and the length of CB is 2 times x. Of course, this is according to corresponding sides of similar triangles. Therefore, I can say that Gn upon Gb is equal to x upon 2x, and x upon 2x, x cancels. Therefore, I get Gn is to Gb is equal to 1:2, which means that Gb is to Gn is equal to 2:1, and that means G divides. So this would imply that Gb is to Gn is 2:1, and this therefore implies that centroid G divides Bn in the ratio 2:1, and similarly even GC is to GM will be 2:1. So that is why we considered that centroid divides a median in the ratio 2:1, and this concept actually helped us derive the formula for centroid of a triangle. So again, pausing for a minute before we summarize what all we learned today. So let us summarize what all we did in this particular session. So section formula: if point P divides the join of these 2 points in the ratio m:n, then this particular formula can be used to find the coordinates of P, and P divides AB into 2 sections. So that could be the reason why this is called the section formula. It makes 2 sections of the line segment AB. There is a very nice and easy pattern to remember the x and y coordinates of P. Cross multiplication is a great tool here. So m multiplied by x2, so that's mx2, plus n multiplied by x1, that's nx1, divided by m plus n, comma, to find the y coordinate, again you take the y coordinates of A and B and use the cross coupling effect. So that's my2 plus ny1 divided by m plus n. These are the coordinates of point P. Please note that here we have P divides the join of A and B. So A is the first point that is specified, and that is why we denote M between A and P. That is a very important thing that you should remember in section formula. and B is the second point that was taken up or mentioned. That is why the ratio, the denominator of the ratio, that is n, is always applied to the distance between P and B, right? So this is a very important idea in section formula. So this is how you can remember the section formula. Now there were two important outcomes of the section formula. One was the midpoint formula and the other was the formula for centroid of a triangle. So if P is the midpoint of the line segment joining A and B, then the coordinate of P can be found out using the midpoint formula. So x coordinate of P is basically the average of the two x coordinates, that is x1 plus x2 by 2. And the y coordinate of P is also going to be the average of the two coordinates, that is y1 plus y2 by 2. So the midpoint formula helps us find the coordinates of the midpoint. And the next outcome was the formula for centroid of a triangle. So centroid G of a triangle formed by A of x1, y1, B of x2, y2 and C of x3, y3 is given by the centroid formula, which is G of, if you notice in the midpoint formula you had the average of the 2 points, whereas in centroid we find the coordinates of centroid as x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 divided by 3. This is how we find the formula for centroid of a triangle. So this is what we learned in today's session. I will pause for a minute before ending today's session. Ending today's session here.